Dear students, today we are going to see solid state. In solid state, close packing in metallic crystals. Okay, so first one, closed packed structure. Closed packed structure. Structure in metallic crystals. Metallic crystals. So what is close packed? Close packed means we have seen previous classes, primitive cell, non-primitive cell. So if you take ionic compounds, so how each unit cell, how it is arranged in the crystal. Okay, unit cell also contain different atoms or different particles. How the different particles are arranged in different unit cell, so that it gives a metal lattice or crystal lattice. So the spheres are arranged, we assume ionic compounds means made up of ions, sodium plus and Cl minus ions. Okay, so our two metallic crystals, everything is arranged by metallic atoms. Copper means only copper atoms, gold means gold atoms. So how these particles are arranged in the crystal? Normally we assume they are spherical spheres. Okay, sphere we assume, and how in different way the atoms or particles are arranged in the crystal lattice. Okay, so the arrangement is such a way so that they leave less space in the crystals. Okay, so first one, closed packed structure we see in one dimension. So one dimension in one dimension, that is, it is given in your NCERT textbook. One dimension means just we see that they are like which one? Spheres. But when we see this one, we can write this one 1, here 2, this 3, 4, 5, 6, 7. Okay, it goes like this one. So suppose we take this sphere. So this is the adjacent one, this is the adjacent one. So in one dimension, the coordination number is equal to 2. What is coordination number? Coordination number is the number of nearest neighbor. Number of nearest neighbor. Coordination number is the number of nearest neighbor. You see this one, you take any sphere, what is coming here? This is one, here another one. So this is another one, this is another one. So here coordination number is equal to 2. Sometimes students write this one, number of nearest neighbor, or number that is the coordination number. Or sometimes they write the number of spheres touching the given sphere. That always, in every case, it may not be same. Okay, it is not correct. So always, whenever they ask what is coordination number, please write this one. It is the number of nearest neighbor, that is coordination number. Okay, so first one, this is one dimension packing. Second one is two dimension packing. Two dimension packing. In two dimension packing, we are going to study, number one is called square close packing. Square close packing. In square close packing, how you write when SCP? This is square close packing. In square close packing, you see here, so first one we'll arrange this one. 1, 2. We can write from here 1, 2, 3, 4, 5, 6, 7. Okay, near you have to here you cannot draw exactly the same sphere type, just we can see one round. Okay, this is layer A. Next one, another one, you see 1 here, 2, 3, 4, 5, 6, 7. This is a second layer. Third layer, Third layer is 1 here, 2, 3, 4, 5, 6, 7. Many will be there. It will be extended that side also. It will be extended this side also. It will be extended this side also. That means horizontal way also it becomes bigger, longer. Then vertical ways also you can extend it. Okay, but you take this one. Any one sphere you take. Suppose you are taking this sphere. Okay, then suppose you draw the square. So if you draw like this one, 1, 2, 3, 4. Okay, it gives a square shape. So what's the coordination number here? Coordination number is equal to 4 here. Okay, or just you see here, if you draw this one, suppose for example here 1, here 2, here 3, here 4. Okay, we are taking this one. So but in 2 dimension we consider them, when we see this one, we consider them as a circles, not sphere, circles. Okay, here you see, here coordination number for this sphere, coordination number, this is 1, this is 2, this is 3, this is 4. So you touch any sphere, you can find that one coordination number in square close packing is 4. So if you see this one, that nearest neighbor, if you join, you get a square. So it is square close packing, right? Now you see here, if you draw this one, here we are not measuring and drawing, just imagine. We are imagining and drawing that one. Here you see between any sphere, suppose you 1 sphere, 2 sphere, 3, 4, 5. Always there will be some gaps will be there. Okay, this gap is called voids. What this one? Either these gaps left or vacant spaces left between the sphere. You can write which one? Vacant spaces left between the spheres, between the particles. Particles is equal to, is called voids. Voids are interstitial sites. Interstitial sites. Then we'll study different type of sites afterwards. Okay, now see here, first it is there, just to imagine this is the plane surface. You are arranging one layer here, the next layer here, the next layer here, the next layer here, this one. Okay, so you are not stacking on that layer, so it's a base layer. So if you take that one, each atom is, in each atom it is surrounded by 4. That means nearest neighbor is 4. So structure you are getting square structure. So this is called square close packing. Okay, here all the spheres are, this is square close packing for touching spheres. Touching spheres means there are some, we'll study later, non-touching spheres also it's there. Okay, here it is which one? Touching sphere. The next one, then square close packing, you see, when you extended the square close packing in 3 dimension, you will get cubic structure. Okay, that means you are getting primitive cell. So you can, very important point here, when square close packing, when square close packing in 2 dimension is extended, it gives to cubic structure. Cubic structure means what you can explain? Ordinary primitive structure. Okay, this is very important point. Now we'll study for 2 dimension square close packing, what is the area of efficiency. Okay, area of efficiency. Area of efficiency. Area of efficiency you see here. Here how many are there? Nearest neighbor you see here 1, here 2, here 3, here 4. So 4 into. If you see this one, only if you take this one, only this portion belongs to this one. Okay, only this portion. The square cover only this portion, that is 1/4 of the circle. We are because when we see this one here, we are 2 dimension, we don't take it as a sphere, we take it as a circle and we calculate. So 4 into 1/4. okay, into pi r square into 100 divided by a square. A square. Okay, here a square, what is the value of a square? This is a. So here you see, when you see this one, a means this is r and this also r, means when they come together. So we take normally a is equal to 2r. A is equal to 2r. So how will we calculate a? So this is the formula, 4 into, I think I understood 4. 4 is the here 1, this is touching 1, this 2, this 3, this 4, 1 by 4. From each circle, 1/4 is coming in this square. Then circle pi r squared into 100. So how will you write this one? Is equal to 4 into 1 by 4 into 3.14 into r square into 100 divided by 2r square. So if you simplify this one, you get what this will be cut off. Okay, r square will be 2r square. So this will be r square. 2r square means how will be there? 4r square. This and this will be cut off. Finally, you will get almost 78%. Okay, how much you will get? Which one? 78% is occupied by the sphere. Is it clear? That's in 2 dimensions. So very important point is 2 dimension sphere. When it is extended to, what you can tell, which one? In 3 dimension you will get cubic structure, that is primitive cell. Okay, then second one is hexagonal close packing. Next one is hexagonal, number 2. This is also 2 dimension hexagonal close packing. Hexagonal close packing. Close packing in 2 dimension. 2 dimensions. Okay, so first how will you draw this one? First we are drawing the first layer. Okay, first. So how you take this one? Number 1, 1, 2, 3, 4, 5, 6. This is the first one. Okay, next layer, how will you draw the next layer? That's a depression of these 2. So 1, here 2, 3, 4, 5, like this. The next one exactly below this one. So 1, 2, 3, 4, 5, 6, 7. Next layer is first one, this one. This is the second one. This is the third one. So what we can do in between these 2 now. So we can tell this one, second layer comes in the depression of the first layer. Okay. So you are drawing this one first and third. The next one is fourth layer come exactly below the second layer. 1, 2, 3, 4, 5, 6. Okay, you take this one. Suppose for example you are taking this layer, means this sphere. So here how will you see? If you collect this one, you join this one, 1, here 2, here 3, 4, 5, 6. Okay, so you will get hexagonal shape. So this is called hexagonal close packing. Okay, next one is, what is the coordination number for this one? Coordination number for this one is 6. See here, suppose you are taking this sphere. Okay, so or you can take this one. Here is the coordination number. This is number 1, this is 2, this is 3, this is 4, this is 5, this is 6. So coordination number is 6. Okay, here we see here in hexagonal close packing in 2 dimension, there is coordination number is 2. Coordination number is 6. So see here, this is the ones. This is the one sphere. 1, 2, 3, 4, 5, 6. Okay. Now see here, if you want to see this one, area of efficiency, we can see area of efficiency. Efficiency is equal to, here how many spheres in hexagon? No, in hexagon, how many spheres are there? 6 spheres. 1, 2, 3, 4, 5, 6. 6 in 2. So here this portion. From this portion now the sphere, this area only comes here. 1/3 of the sphere. So 1/3 plus. So from here 1 by third, from here 1 by third. So if you draw like this one, 1 here, you are getting like this one, no? See here. So this area 120 angle. That means in 360, 120 is actually 1/3 of the sphere. So 1 by 3 plus in the middle 1 sphere is there. So 1 into pi r square into 100, because we see as a circle, divided by 6 sphere into what is the hexagon? Hexagon area 6 into root 3 by 4 into a square. A we say which one? Here a is equal to 2r. So a square, what will come here? A square. So here 6 into 1 by 3 plus 1 into pi r square. That means 3.14 into r square into 100 divided by, here what will come here? Which one? 6 into root 3 by 4 plus 2r square. So okay, 2r square is a square is equal to 4r square. If you simplify this one, what you will get? This one here 2. Everything if you simplify this one, you will get almost 91%. So 91% is occupied by sphere. So its area of efficiency is 91%. When if you see this one, when compared to square close packing, the hexagonal close packing is much efficient packing. Okay, if you see, you can understand, because the first layer, second layer, we are arranging the depression of the first layer, so voids are much lesser than square close packing. So what we studied now, square close packing and hexagonal close packing, both are in 2 dimension with touching sphere. Touching sphere means each sphere is touching the other one. Okay, so next one we can see this one. So very important point. What is the important point? When hexagonal close packing, hexagonal close packed structure, when extended in 3 dimension, if extended or when extended in 3 dimension, we get CCP and HCP structure. This is the base structure for CCP and HCP structure. Here you see children, don't get confused. This is area efficiency, not volume packed by the sphere. It is the area of efficiency, efficient packing. So okay, so these two finish. The next one I told you, sometimes the arrangement comes then spheres with non-touching sphere. So non-touching sphere, how it comes? Somewhere one non-touching sphere in square close packing. Okay, square close packing. So it will be like this one, 1, then 2, then 3, then 4, then 5, then 1, 2, 3, 4, 5. They are not touching each other, but the gap is there. It is arranged like this one. So if you see this one, this 2 give the unit cell, not unit cell, this is square, it gives the 4. If you connect, you will get square close packing. But here which one? How you find out this one? A R, if we know the value of R, if we know the value of A, we can calculate what? We can calculate the area of efficiency. So what's the coordination number in this case? Coordination number will be 4 only. So it's suppose, for example, if you are connecting this one, 1, here 2, here 3, here 4. Coordination number will be 4 only. Coordination number is 4. So normally students, what they tell, the coordination number is equal to 0. They say which one? 0 is not correct answer. Coordination number will be 4. So if you see this one, this is the nearest one. If you see this one, this is the nearest one. This is the nearest one. This is the nearest one. So the coordination number is the number of nearest neighbor is called coordination number. Not always the number of spheres touching the given sphere. In sometimes the spheres are the sphere arrangement may be without touching. Non-touching sphere also is there. So you remember this one. Coordination number is a number of the nearest neighbor in the given structure of the crystal lattice. Okay, thank you. The remaining 3D dimension, three-dimensional packing that we see in next video. Okay, thank you children.